Hi, everyone. Welcome to Unfiltered Flow ELSC. I'm Megan Cook here with Alan Burdett, and today it is our pleasure to have Mr. Barun Acharya from Parker Hannifin. He is the Systems Application Engineering Manager.
Thank you very
Welcome,
much.
Barun.
Thank you, Megan. Thank you, Alan.
Pleasure to have you.
Thank you so much. So my favorite question to ask Barun is, how did you get into fluid power?
So I came to US for my master's for my grad school, just like many of the folks from India show up here. And I went to Oklahoma State University for my master's in mechanical engineering. And they had a pretty good hydraulics class, which I didn't know, but I attended one of them. And from there, I got a job offer from Eaton Corporation. They had a plant in Shawnee, Oklahoma. And that's kind of how the hydraulics stint started. Initially, I thought it was a dead field, but once you go into the hydraulics field, it's kind of like a quicksand. I think you just keep going deeper and deeper into it. So from there, I moved to the headquarters of Eaton. That was in Eden Prairie, Minnesota. So that's where we did a lot of design work on hydraulic pumps, motors, all kinds of brakes and other components, and also systems. And then from there, I moved to Parker Hannifin. Parker Hannifin mostly on design of components, pumps and hydrostats, things like that. I worked with Al on that. And then from there, I've been with Parker ever since. From there, I moved to Chicago. That's the headquarters for the systems team. And so I worked in the hydraulic systems for a while. And for the past 7 years or around that time, I've been focused on electrification. So I saw the trend in electrification and I loved it. So I've been working on electrification since then.
Okay. Can you tell us about some trends you're seeing in electrification of fluid power systems,
Yeah, so
Barun?
I would say electrification of fluid power system, that is kind of the trend that's in vogue lately. But the recently, I would say the rate of adoption of the electrification or lack of adoption, I think I would say that kind of surprised a lot of people, including our team. So things are going behind schedule from what we assumed, but it doesn't mean that it's not going to happen. We think it's just delayed by certain years, but it's still happening. So electrification is for sure still in vogue. A lot of people working on a lot of inquiries. It's just a high volume adoption hasn't happened yet. Some of the challenges lately has been more on the supply chain side as well, with the tariffs, with the rare earth, all kinds of issues there. But, I'm sure we're going to overcome all this challenges. And then beyond that would be, seems like the efficiency has been the focus on electrification. And we are looking at holistically how to address the efficiency system with the electrification. So basically, to answer the way I would answer it is like hydraulics is kind of the muscle or the brawn, if you would. With electrification, we're giving it some of the brains, if you would, more finesse, and we are right sizing the hydraulics. Before the hydraulics was always oversized, in my opinion, for any application. Now we're right sizing it. And then basically the idea is to make sure the yield is giving you, with the less inefficiency, it's giving you the useful work that you need. And then also creating less heat in the process, doing the right useful work. And then also the controls giving you the edge and helping the customer with a beautiful solution. That's kind of the way I describe electrification.
What are the particular industries that are adopting the electrified fluid power solutions
Yeah, so
today?
in our opinion, what we have seen is like a lot of it's really the government effort, that's kind of leading the business case, and so many of the ports are kind of leading the activity. So whether you look at the seaports or airports, so there is all these initiatives by the different state and the federal government to eliminate pollution. Those are the areas where we see the leading in terms of, and then besides that, I would say terminal tractors would be one application that's been going into electrification in terms of commercial usage, and also some small compact construction equipment would be the other one I would say that we have seen a lot of adoption of of electrification, especially where the duty cycle is low and the power requirement is kind of on the lower side. That's where we see the big adoption for the electrification and for hydraulic equipment or fluid power equipment.
Along that line, without giving away any trade secrets or company secrets or anything, is there an example of a project that you could give us where electrification significantly improved a system?
Yeah, so let's talk about a couple of examples. So the first example would be let's talk about a small mini excavator, like a 2 ton, 1.5 ton, or in that range. So, in a typical mini excavator, you would have a big engine, and then you're going to have 2 or 3 pumps tied to that. And then from the pumps, you're going to have hoses going everywhere to all the different actuators. So that has been replaced by a more decentralized system where you replace the engine and the centralized pump with e-pumps. So we have different architectures, 2 or 3 e-pumps, some tandem pumps, and then the valves are more on-off type valves, and then your e-pump is kind of producing the flow that you need. So basically what that does is 2 things. You can use that mini excavators indoors where you cannot, before you couldn't use with the IC engine, you have to turn off you couldn't just use it. So now with the IC engine, that's a big positive. And then the other thing is the noise. So if the operator is using it all day long, they feel much more refreshed after using this. So those are the other benefits, if you would. So, but basically the idea is with a mini excavator, you can see how the efficiency of the system grew from a IC engine versus electric system, and also the controls, the controllability, things like that. The other example I would give is probably the bucket trucks. So this is the work truck industry. You see the bucket trucks, working on the electric lines we have. So there you have a e-power or e-pump system, if you would, that ties to the IC engine system, and you have an anti-idle system. You could turn off the engine and you can run the bucket and you can position your bucket much better. The person up in the bucket can talk to, basically it's a 2 team member, so the person in the ground, they can chat just to talk normally and listen to each other. So much more safer system, if you would, and a much more efficient system as well. So those are the 2 examples that comes to mind.
Okay.
Barun, how are battery technologies influencing fluid power applications on the electrification side?
Yeah, so battery to me is one of the key component, so if you look at the bill of material of electrified equipment and compare that with the IC engine machine, the cost of the battery, if it's a fully electric machine, is almost 80% is of the cost is from the battery. I mean, I'm making an generic example here. It depends obviously on the duty cycle and things like that. But with that heavy a cost, so one is cost, and then the other point is the way to think about a battery is like a fuel tank, but it's super heavy, and super heavy because the batteries are very heavy. So gravimetrically, not just volume wise, also weight wise, they're a big negative. So you have to carry them around, and that robs you from doing, so that's number one. And then so cost, the heavy weight. And then the other piece is, imagine a fuel tank, which you cannot even fill up very quickly, is the other challenge. So you have to fill it up slowly. Unlike a fuel tank, I can fill it up in a few minutes. This takes overnight, and there are implications if you do fast charging. You have implications, so you have to make sure you slow down from state of health perspective. So battery is a key component. The other piece is you have to also keep in mind the thermal management of the battery. The batteries don't like to work at lower temperatures, so you have to keep that in mind. Maintain it between -20 or 60 degrees. And then also the rate of charge and discharge, they also change depending on the temperature. So thermal management becomes key. The controls becomes a key, how you charge it and discharge at what rates. So that's why battery becomes a very, very critical component. There's a lot of activity going on the battery side from at least the part that we are in. We are more users of battery. At Parker, we don't make batteries. However, our group at Lord, who do a lot of engineering materials group. So they have a lot of cool technology. They work with all battery manufacturers. So our goal from a systems engineering perspective is to work with the battery, work with customers in figuring out what is the right battery chemistry, and sizing the system, based on the duty cycle and things like that.
So that's interesting because it sort of leads into what I wanted to ask next, and that's when you look at a machine, how do you determine what functions you're going to do hydraulically and what you're going to do electrically? It just is it duty cycle? Is it the amount of work that needs to be done? How do you decide which you're going to do in what
Yeah,
manner?
that's a great question. I mean, there is no generic solution, Al. So there's no one size fits all. So I mean, that's the good news. That's why we have a job and our team have a job. So we like it. So the way is you really have to understand the duty cycle of the application. So number one, as an application or a systems engineer, the way is you have to really truly understand what the application needs are, the duty cycle needs are, the power needs. If there's a burst of energy needs, and you have to map it. And you also need to know the edge cases because typically hydraulic application, it's not like a typical car we have, people drive 99 percentile falls into a certain category. Your roads are all paved and things like that. But for us in the off-highway applications, they are all over the cases, so it's pretty nomadic in nature, the duty cycle. So you have to truly understand the duty cycle. That's number one. And number two is you have to map how the energy is used after that. So you have to figure out where the energy is going into which functions and how much of it is really converted into useful work. So this is what we call the energy mapping exercise, so that's the next step. I think simulation plays another important role there, where you have to figure out, you have to simulate, here's my existing state, here's my proposal, whether it's a electric hybrid or fully electric solution. And then once you simulate that, then you can figure out in terms of sizing, and then you come up with different proposals if you would. But at a high level, that's kind of the way we attack the problem. And then, of course, the thermal management and then the solution. But I think the key point I would say is when you electrify, say, imagine you have a off-highway application, a customer comes to you. So, we used to bucket the customers. Step one would be eliminate the engine, just put an electric motor and a motor controller, and off you go. So that would be my category of customer one. And then after that, we know that's not the right solution. The customer goes back and comes back. They're like, oh my God, this is horrible. My battery barely lasts for so long, So then we say, okay, then he's like, oh, the customer is like, okay, make me the most efficient system. So now we go in the other side. We over design, every axis may have a, electric motor driving some pump or whatnot, or electromechanical actuator. But then it works really good and it does the job. But then they come back, the cost of the system is super high. So it's the phase three when the customer comes to, that's when I know they're ready to go into production. So this is where you kind of balance the two, and you have to figure out the total cost of ownership. So at the end of the day, that has to make sense. Otherwise, it's just an engineering exercise, a science experiment rather than a real commercial solution.
What do you think the future of electro-hydraulics looks like in mobile equipment and industrial automation, Barun?
Yeah. So my domain is mostly off highway, just so you know. So I barely ever worked on industrial applications, so I wouldn't go there. But I think the future is very bright, in my opinion. Like I said, electrification is going to happen sooner or later. So I think what's going to happen is the line between electric and hydraulic is going to get blurred as the time progresses. So people are gonna, it's gonna be everywhere, the combination of electric and hydraulics. We are gonna, basically, so say for example, back to my excavator example, so you could imagine you have the bucket, the boom, and the stick, so those you may want to keep it hydraulics because, the hydraulic cylinder, the bucket shake, the amount of shock loads and things like that. However, for swing, that could be electromechanical, and I could recover the energy back when I'm braking. So these are the kind of solutions that going to be very common in my opinion, and electric and hydraulics are going to work together. The hydraulics components are going to be much more smarter. There's going to be more sensors there, so you can talk to it. It's going to tell you how much usage you actually used, how long, how many hours, how the duty cycle profile was. It's just because with electric, I already have built-in sensors. So it's going to be just the data is available. So I think it's going to be super exciting. And like I always tell our sales guy, when we have an electrification project, the objective is not just selling the electric components. It's really selling the electric components and also redesigning the whole hydraulics. That's the beauty, to be honest, at this time, So right now in this era, imagine, when at least when I was young, I mean, hydraulics was kind of like a old, mature field, you go and talk to them about a component. Now here you get to talk about electric, you get to talk about the hydraulic system, and you got to talk about controls. So you get to sell the whole system all over again. And to me, that's the most exciting part. I don't know if I answered it properly, but I just get excited about that.
I can understand why.
Mm-hmm.
What should OEMs and system designers be thinking about now to stay ahead as we transition into these hybrid and electric options? I mean, is it controls? Is it, I don't know, AI? What
Yeah,
is
I
it?
think that's a great point again. So to me, I think one thing that I always notice, like, when you go to a customer, they have clearly defined people, so they have hydraulic domain experts, they have controls people, and then they may have now electric people, like the power electronics guys, but they are all different people. So, but I think that needs to be like more a cross-functional. They need to intermix. They need to know about each other's domain. So to me, that's probably the biggest thing I would do or I would recommend to them. And then I would also say, let's make some pilot projects. Don't be, let's create some electrified system, maybe hybrids, because hybrids probably make more sense in many of the equipment that we work on, like off-highway type applications, and let's learn from them. I think there is a lot of lessons to be learned when you do these pilot projects, and then also use that as a training bed for the upcoming engineers, and you make them cross-functional domain experts. Maybe focus on simulation, because I think simulation has a lot to play. Just because the duty cycles are all over the place, you don't want to over design things because it's very expensive. At an operations level, I would say supply chain becomes critical. I would make sure the supply chain folks are up to the standard, that they can handle the what's coming. And then, of course, controls is also the key. But again, that's just another piece of that. So I think that's what I would recommend at a high level, what the customer should do. And then also, I would say involve different people, involve suppliers, and key suppliers. There's a lot of knowledge out there, and people would, this is the time to share, go to conferences, and you can come up with some really good ideas, and you can get the ROI very quickly, in my opinion.
This leads into that, Barun. What do you see as the primary barriers for adoption among customers at this point? The cost you'd mentioned there, knowledge. What do you see now?
Yeah, I think cost is, I would say, is number one, So it's the sticker shock, So when you look at a IC machine versus an electric machine, when you have 2 to 3x the price, the sticker shock is kind of a big deal, in my opinion. So I think the customer needs to. I think we need to do a better job in making the end user understand, the value prop properly. So I think we need to help them identify that, in my opinion. I don't think we do a very good job there. And then maybe focus more on the total cost of ownership. Just don't look at the sticker price, the capex, rather than the operating expenses as well. And then help the person understand here's the total value if so to me, the TCO, the total cost of ownership becomes the key, the maintenance savings, things like that. And then maybe that's why we have to create these pilot projects and we have to show it to them. So there is more, more openness from the customer standpoint to adapt this solution. And I think we also have to do like a scalable solution. So imagine, I think one of the challenges right now is you go to any customer or end user, they're going to say, I have 90% of my machines are going to be IC. Say 5% or very small percentage is going to be EV or hybrid. So you want to make sure there is some sort of a continuity amongst the components they're using as well. So I always say that maybe the solution would be you look at the 90%, let's make the hydraulic system similar to the other 10%. So it's easier for them. So it's higher efficiency. Maybe the ROI doesn't make too much sense from the IC engine, but when you look at the electric system where the batteries are 80% of the BOM, it totally makes sense there. So there's different ways to skin the cat, but I think you have to document it and you have to explain it to the customer, maybe capture all that data, show them how the person is using it. It's so much easier now to show if you have a electrified system, how they are using the system, what's the duty cycle, and, you know, and how they could do better.
Yeah, I think a portion of that too is probably training or retraining the sales force to be able to articulate that
Yes,
to the
absolutely.
customer base.
So, having known you for a while as a hydraulics guy, I was a little surprised to see you go into the electrification slash hybrid role there at Parker. What what drew you to that, or were you just thrust into it, or how did that work?
Yeah, so my life was more about designing components, so designing hydraulic components. And then once I went to the system side, that's when I realized how inefficient the hydraulic systems are, to be honest. So I was like working all day.
We may
We
have
may
to cut
have to
that
cut that
part.
out.
We're working all day and night to get 1% volumetric efficiency. And here they piss it all away. Oh, sorry. They just throw it all away. I was like, what the heck is going on here? So anyway, that was my first thing. And then I saw, what kind of system gains have we made? Not much. It's a very conservative hydraulic industry, you all know, it's very conservative. Like the latest state of the art is a load sense system that was designed in the 80s. So that is state of the art for a hydraulic system. Of course, I must say it's very reliable. Cost is low, but it's very inefficient. So here was it's not like the hydraulic systems guy. We don't know how to make efficient system. Of course we do. We know how to make precise system. But the problem is it didn't make sense before. But with electrification, with the cost of the batteries, I thought here's a chance to take this hydraulics industry to the next level. So that was kind of my reasoning, Al, why I thought. So I just couldn't resist. This is ideal. And then I always loved the idea of the challenge. Getting to know another domain, and then where you can do the electric domain, the hydraulic domain, and the controls all three together, and come up with something much better. And that was just too exciting to let go. So
Yeah, I imagine it was. I imagine it was. Yeah.
Speaking of challenges, so what's the most interesting or challenging project you've worked on so far in this domain?
I think the most challenging project was the one we worked together on the turf side. So that's not an electrification project. So we'll talk about that. That was the integrated hydrostatic transmission. To me, those were kind of my most challenging and most exciting days, in my opinion. So especially where it went after what we did. But on the electrification side, I think the most challenging was during the COVID days. I worked on a project where we downsized. Basically, we made a hybrid backhoe loader. So we downsized the engine from 75 to 50 horsepower because at 50 horsepower, the tier regulations were much lower. That was the reasoning. And then instead of having a big battery, we sized the battery the right size, and you could operate the backhoe loader indoors for 45 minutes. And so basically it's a fully electric machine for 45 minutes. And then the system was below 96 volts. So we had to think about functional safety, security, the safety side as well, and then do the controls. And this was a manual controls, a backhoe loader, taking it to the next level with, I mean, that was just super exciting. And that kind of, plus that kept me sane, because I hate working from home. That made me come to my lab and work on the machine. So that was probably the best project on electrification that I worked on. And we learned a lot together. We came up with adaptive controls. So, and then we made this hybrid system, which is smart, and then you charge the system, run the engine at the sweet spot. So a lot of learning. So that was beautiful.
Yeah, that's great. So if you could go back and give yourself one piece of advice when starting in this niche area you're in now, I guess it's okay to call it a niche area. What would that one piece of advice be you would give to yourself?
I think it would be to learn as much as possible about the fundamentals. I wish I knew more about I still struggle with the power electronics basics sometimes. So, and I'm trying to get better at it. And especially with AI, with ChatGPT and things like that, learning is so much easier now. So, but I think that kind of helping me. But my recommendation to myself would be, learn as much as possible about the different domains, not just mechanical, fluid power, electronics, controls, like controls. So many challenges, still learning a lot there. And then what else? I would say communication was the other key thing. It took me a while to figure out, how you communicate, break it down into simple steps. You have to communicate it to your boss, to your managers and the customers, in a simple way. And that really sets you apart. Even if you're a good engineer, if you're good at communication as well, that sets you really apart from other people. I don't know. I wish I would also ask myself to buy Bitcoin 20 years back, maybe.
Wouldn't we all?
Well, Barun, we appreciate your time. Thank you so much for taking time out to
Thanks
talk
so
to us.
much. It's been a pleasure, and it's so great to see you, Al, and nice talking with you, Megan. Thank
Nice
you.
to see you
Thank you
again,
both.
too.
Thank you.